Hi, I'm John with Page Tutoring, and today we're going to be covering Eduqas's GCSE mathematics paper for autumn 2023, and this is the calculator allowed paper. First things first, let's start by looking at what you will see straight away on your exam desk when you turn up on the day is the front of the paper. Now you're going to fill in your name, your centre number, your candidate number, all that good stuff. But there's also some important information to remember when first looking here. So we could see that this paper is 2 hours and 15 minutes. So that's about a mark a minute. You've probably heard that phrase a lot. For each mark, you should only spend a minute on the question. So looking at additional materials now, this tells you what additional things such as a ruler and a compass you might need in the exam. So yes, it says here you may need a ruler, you may need a protractor, you may need a pair of compasses. So if you ever come to a question and you're a little unsure, you think, I think I might need to use a ruler, not sure on that. If it says in the additional material you might need to use it, the answer is yes. In that question, you probably do need to use that ruler. Now, coming on to the number of questions, we've got 25 questions and 120 marks in total to gain. With Eduqas Foundation, around 60 to 70 marks will get you the maximum grade that you can get in Foundation. So that's a grade 5. Between these mark boundaries, there's about 10 marks. So every single mark you get out of that 120 is 10% closer to the next grade up that you're aiming for. Now, these 120 marks, with this being just the calculator paper, that's 50% of your total mathematics GCSE. So this paper's worth 50%. So now if we go on to the next page, you will, well, at the moment, there's chatters of getting rid of the formula paper. I've heard from some of my math teacher friends. But for now, you will get a formula sheet. It will look something like this formula sheet here. So here we have areas and volume formulae. So if you're asked to find a curved surface of a cone, something to do with sphere, you have all these formula here. So you should go to the front, take the formula, substitute in the values for length or radius, for example. And then you have your kinematic formula here. So that's stuff to do with distance or velocity. So once again, if you're asked something to do with that, just come to the front of the paper and all of the formulae are here. Question 1. The table below shows the cost to post letters and parcels. So we've been given a nice little table here. We've got small letters, large letters, parcels, and we've got first class costs and second class costs. And then it goes on to say, use costs from the table to answer the following. So part A, Maria posts one second class small letter. So as we're reading this, we can start writing down information. So one second class small letter, second class is 68p. And one first class parcel. So now we'll go back in here. So we've got parcel, first class. So that is £4.45. It says, what is the total cost of posting these items? So we've got our values here, and all we're going to do is put this 68p, or you could also write that as £0.68, plus your £4.45. And we're just going to put that straight into our calculator. So this is a calculator paper. If you're allowed to use it, you should use it. So 0.68 plus 4.45. Double check that's right. Yep. Equals. And then if your calculator is set like this virtual calculator is, it'll come in as a fraction. But all you need to do is change the format. So some calculators, it'll say format somewhere at the bottom, now where it says answer. For this one, it's just this here. So it goes from S to D. So if we click that, and there we go. So we have there, so that's £5.13. So now we're going to go on to the next question. B. How much less does it cost to post 3 large letters second class and to post 3 large letters first class? So let's write that down. So how much does it cost to post 3 large letters second class? So we're going to put a number 2 here to show our second class. I'm posting 3 times the large parcel second class, that's £3.35. For first class, that would be 3 times £4.45. So once again, we're just going to substitute these formulas straight into our calculator. So we're going to do 3 times 3.35. So that's £10 and 5 pence. And then we're going to do 3 times £4.45. And that gives us £13.35. Now, a lot of people will stop at that point and go, okay, I've worked them both out. That's only 1 mark. To get a final mark, we need to know what the difference between these two are. Once again, you've got your calculator. If you're ever in doubt, you're feeling really nervous and you can't do it in your head, just get that calculator back up and do that subtraction. So we've got £13.35 already on there. So we're going to minus our £10 and 5 pence. So that's £3.30. Because it's in pounds, though it's 3.3 in the calculator, 0.3 of a pound is 30 pence. So we've got £3.30. And that's your 2 marks. Part C. Gareth spent £15.95 posting large letters first class. How many letters did he post? So of that £15.95, he's only posted large letters. So if we want to find out how many large letters he has posted, we're just going to divide that £15.95 by the cost of a large first class letter, which is, looking at our table, £1.45. £1.45. So if we're going to find out how many lots of that £1.45 are in that total cost of £15.95. So let's get our calculator back out. So we're doing 15.95 divided by £1.45. And we get exactly 11. D. Lee has £3.50. Does he have enough money to post 5 small letters? Yes and no. So first we need to know how much would it cost to post 5 small letters. So it would be 5 times the cost. And if we scroll up, let's start with the lowest cost, because it's either going to cost 95p for first class or 68p for second class. So we're more likely to be able to post 5 lots of cheap letters. Let's have a look. So if we do 5 times 68p, get our calculator up, and I'm going to type this in as 0.68 because 68p is 0.68 pounds. So that is equal to £3.40. Once again, if it's 3.4 on the calculator, that's 40 pence. That 0.4 is 40 pence. So it's £3.40, and we can write that that is less than £3.50. So does he have enough money to post 5 small letters? Yes, and you should write, just in case the examiner's feeling mean, that this is second class. Question 2. We've got a grid and we've got shape A. Shape A is shown on a 1 centimetre grid, so each one of these little squares is a centimetre. Question A states, or asks rather, on the grid below, draw a square that has the same area as shape A. The first step is, what is the area of shape A? Well, because this is a scale grid, we could just count the squares nice and easy. So 1, 3, 24, 25. So that's 25 squares, or 25 centimeter square because of the scale of the grid. So now we know the area, well, squares have the same length on every single side. And 25 may look familiar because 25 is a square number. So if we do 5 times 5, that's equal to 25 centimeters squared. Therefore, we can draw a nice square here with 5 centimeter sides. So 1, 2, 3, 4, 5. And for this, you'll use your ruler. I'm just using the software that I've got. 2, 3, 4, 5. 5. And finally, 5. Part B. Work out the perimeter of shape A. Well, the perimeter is when we count up all of the edges. We're going to use red to go around the perimeter. So if we count this perimeter here, we've got 3. Going down here, 5, 2, 2, 5, and 7. And then we're just going to add all of these up. 7 plus 3 plus 5 plus 2 plus 2 plus 5. Feel free to use your calculator. In this instance, I'm just going to add that up, and that is 24 centimeters. So if we now go back to our part B, zoom in here, we can write that that's 24 centimeters, and you can even write counted all edges. Part BII. On the grid below, draw a rectangle that has the same perimeter as shape A. Okay, so we want a rectangle, so we know that the sides are not going to be the same. Well, 2 of the sides are going to be the same, and then the other 2 are going to be the same length. And we want it to be 24 centimeters. So you could just go, okay, I've got 24 centimeters. I want 2 of my sides, 2 times, to be 5 centimeters. Okay, well that adds up to 10, which means that I'll leave 2 of the other sides to be 7 centimeters. And that adds up to 14. So yeah, that adds up to the correct perimeter. All I've done there is arbitrarily gone, okay, 2 of the sides are going to be 5 centimeters. It's a rectangle. 2 of the sides are going to be the same length. You could have chosen 2. It would have been a very long rectangle. You could have chosen 8. It doesn't really matter. So now let's draw our shape. It's getting our nice straight line. I'm going to go 1, 2, 3, 4, 5. Down this side, 1, 2, 3, 4, 5, 6, 7. Got 7 down here. And we've got 5 across here. Yours is going to be a lot straighter than mine. I'm just using my drawing tool. And there we go. Question 3A. Write down the number 6,520,000 in figures. Okay, so let's do it. So 6 million, when we have million, that has 6 zeros afterwards. So we can write that down. 1, 0, 0, 0, 0, 0, 0. 520,000, so that's 520. then 1,000, we've got 3 zeros afterwards. Ooh. That's 6 million. So we've got 6,520,000. That's it. So now we're just going to add these numbers together. So we've got 6, 5, 2, 0, 0, 0, 0. Part B. Shade in 3 out of the 5 of the shape below. Well, starting off, how many segments do we have in this shape? So we count it up. Looks like we've got 10 segments. If we convert this fraction here into being over 10, all we need to do is times the top and the bottom by 2. In timesing it by 2, we're not actually changing the fraction, we're just scaling it up to make it easy to work with. So we've got 10 there, we've got 6 there. So that means 6 out of 10, so we've got 10 segments, so 6 segments out of the 10 need to be shaded. So let's shade them in. So 1, 2, 3, 4, 5, 6. Part C. Rearrange these 5 boxes to create a calculation with an answer of 8. So this one is a little bit of trial and error. We've got some pluses, we've got some divides. We can see these numbers here, like 24, that's too big, so we want to make it a lot smaller. So we could just mess around. We've got the space down here, and we could just have a think what we could do. So if we do 24 divided by 4, we'll get 6. If we did 6 and 6, would that help us? No, that's nowhere near 8. So why don't we do 24 divided by 6 instead? Let's try that, because 24 is way too big. We know we want to get it smaller, and to get it smaller, we're using that divide sign. So 24 divided by 6, that gives us 4. And then what we have left is 4 and an addition symbol, 4 plus 4. Yes, that's 8. So we can write this in the order of 24 divided by 6 plus 4. And we can write it in this order because you know, because of BIDMAS rules, that this multiplication, this division here, that's what the D and the M stand for, you're going to do that before you do any addition. So you would do 24 divided by 6 first, and then you would do plus 4. So yeah, that all works out. Part D. Write 465,784 correct to the nearest 10. Well, where's the nearest 10? If we look at our number, and we can zoom in a little bit more to make it easier for our eyes, then 10 in this number is that 8 here. It's 8 right here. So that means we're going to look at the number to the right of it. Okay, that's a 4. And because that's a 4, that's going to round down. So if we now write that, so 465,780. So we rounded that 4 down. The 10 there is that 80. So now we're going to do correct to the nearest 1,000. Well, where would that be? If we write that instead, so we're just going to rub out our previous working out now. We're going to write this in green. So where's our 1,000? Well, the 1,000 start here. And your hint is, you look at 1,000, it's got 3 zeros afterwards, and then your 1 is the 4th number there. So we go 1, 2, 3, there's our 4th number, that's the important one. So once again, we've got our important number, we're going to put some dot dot dots. We're going to look at the number to the right of our important number, that's a 7, which means we're going to round up. So we're going to have 466,000, and that's it, because we've rounded up. That 784 has been rounded up to the nearest 1,000. Question 4. So straight away we see a spinning wheel. We know in our heads it's going to be a probability question, and we can see that just glancing below and seeing terms like unlikely, likely, so on and so forth. So let's read the question. 2 fair spinners are shown below. We've got our crazy spinning stuff, we've got some different shapes, and we'll go question A. Each spinner is spun once, Circle the expression that best describes the chance of each of the following events occurring. So part I, spinner A, so we're looking at the spinner on the left now, lands on a circle. So let's see, if we go to spinner A and we just start totting up all the different shapes, that's a terrible circle, that is meant to be a circle, and then we're going to have our star like that. So how many circles have we got? 1, 2, 3, 4. We've got 4 circles, we've got 2 squares, we've got 2 stars. And while we're at it, because we can see with part II, they're going to ask a very similar thing for spinner B. We'll do the same over there. So we've only got circles and stars here. So of the circles, we've got 2, and of the stars, we've got 1, 2, 3, 4, 5, 6. Okay. So it asks, spinner A lands in a circle, what's the possibility? Well, there's more circles for spinner A than anything else. There's double the amount actually, which means you're twice as likely to get a circle than you are a square, and you're twice as likely to get a circle than you are a star. So it's not an even chance, you're more likely to get a circle, and then it's only going to go up from there. So it's not certain, because there's other options it could be. So we're going to go with likely. It's likely there's more circles, but there's other things it could be. So then spinner B, we've already totted it up, and we're asking, spinner B lands on a square. Well, hang on, if we look at spinner B, there's no squares. We've totted it up, there's no squares at all. So actually that's impossible. There's no squares, it can't possibly land on it. So then we're going to look at part B. Spinner B is spun once. What is the probability it lands on a star? Mark your answer with an arrow on the probability scale. As you can see from the probability scale, probability is always between 0 and 1. Okay, so let's do the probability. Well, the spinner has 8 different segments. So we can write a little 8 here for now. It's got 8 little segments, and out of them 8 little segments, we know that 6 of them are stars. Here it's asking about stars. 8 out of 6. We can simplify that if we wanted to 3 out of 4, or you can just put it straight into your calculator if you can't do it in your head. But that 3 over 4, that's just, so we're going to write that over here, 0.75. So just making that fraction from all the segments in total, which is 8, all the stars in total, which is 6, simplifying it to get to decimal, that is our probability there, that fraction in decimal form. So now we just need to put it onto our nice little probability scale. How many notches have we got? 1, 2, 3, 4, 5, 6, 7. We've got 8 little notches all along here. And actually, before we even got this probability here, if we look back at our original fraction, so out of 8, 6 of them, that means that we could just go to the 6th notch. So 1, 2, 3, 4, 5, 6. Put our little arrow here. That's the end. If you really wanted to, you could do 1 divided by 8 and find out how much each one of these notches is and add it up until you get to 0.75. But we've already got the answer. We're not going to do more work than we need to. Part C. A different spinner, spinner C, is spun once. We don't have a diagram of spinner C. It's just going to tell us about spinner C. So the probability that spinner C lands on a star is 3 out of 16. What's the probability that spinner C does not land on a star? Okay, well, this is sort of a leading question because from part B, that should have jogged our memory. We've just said probabilities between 0 and 1. And in this case, it's saying something does happen or doesn't. Well, the probability of it happening or not happening, that's always going to all add up to 1. Okay, so the probability that it does land on it is 3 out of 16. So that means that the probability that it doesn't happen, this mystery probability number, 3 out of 16 plus that equals to 1. Well, from what we know from fractions, 16 over 16, that would equal to 1. and we want 3/16 add something. So if we make that over 16 as well, that's the something. Well, that thing on top must be 3 plus whatever the mystery number is. That must equal 16. So what do we add to 3 to make 16? Well, that's just 13. And that's it. That's the final answer. We can just leave it as that fraction. Question 5, part A. So now we're looking at a diagram. We've got an angle labelled 3x, and we can see from looking at the diagram what looks like a straight line. So if we write straight line, what we know about a straight line is there's 180 degrees. Okay, so that means that 3x, the angle there, must be equal to 180 degrees. So all we need to do to get x on its own is divide both sides by 3. Divide by 3, divide by 3. So what we get over here is 60 degrees equal to x. And that's it. That's the final answer there. Nice. Part B. Calculate the value of y. Well, we can see from this diagram, when we've got this square shape in the corner there, that means 90 degrees. We know with this 90 degrees and with this angle here, that would, a very wonky one there that I've drawn, but that total angle is 360. So now we're going to make that into algebra. So 360 degrees would be equal to that 90 degrees that we know, plus our angle there. So this now just becomes a solve for y problem. So if we take 90 off each side here, I'm going to take 90, and then that will go to 270. If you're ever unsure, just get your calculator out. Equals 5y. So now, to get just y on its own, we're going to divide each side by 5. So we need 270 divided by 5. Now I cannot do this one in my head, so I'm going to get my nice calculator up, clear it, 270 divide by 5, and that gives us y equals 54. So that's our final answer, 54. Question 6. A, B, C, D is a kite. 3 of its vertices have been plotted on the grid below. So we go down to our grid. We've got our points A, B, and C. Part A is plot point D on the grid to complete the kite. Well, what do we know about kites? Kites are kind of like a diamond shape, like this. Okay, so we know it's a diamond shape. We know that this length here is the same as this length here. We know this length here is the same as this length here. Okay, cool. So we could do measurements like that. But we also know that kites have lines of symmetry right down the middle. So if there's a point here, then reflected in the line of symmetry, we're going to have a point here. Cool. So now if we write in red, we could just put that line of symmetry in. So if we connect our A to our C there, and now we're going to go, okay, well, point B, the point D must be reflected in this line of symmetry. It must be the same distance from this middle bit. So that's 1, 2 distance, and then 1, 2, and we're going to label it D. Rub this out. The other way you could have done it, because we know about these distances with the kite, you could have measured using a ruler or just by eye that it's 2 in the x direction, 1 up in the y direction to get to this point A. So then to get to D, it'll be 2 in the x direction, then down 1 in the y direction. That'll get us to the same point. So now, part B, write down the coordinate of point D. Well, we know that when we're doing coordinates, you write the x coordinate first and then the y coordinate. So if we look at our D, we can see its coordinate is at point 1 on the x-axis here and 0.4 in the y-axis. So you just write that in. 1 and 4. Part C. Draw a reflection of the kite ABCD in the x-axis. Okay. So if we put in a nice red line, so we can see the x-axis, and that's where y equals 0. It's a line, you can see it's marked on here as being the x-axis. So there's your mirror line. So each one of these points has to be the same distance to that mirror line, but on the other side. So for example, C will be just 1 down. Then it's 1 distance below there, so we've got our C, and I'm going to put a little dash up here just so we know it's reflected. So our A is 1, 2, 3, 4, 5 away, so we're going to go 1, 2, 3, 4, 5. A dash. Our D is 1, 2, 3, 4, 1, 2, 3, 4. And our B is 1, 2, 3, 4, 1, 2, 3, 4. And I've labelled all the points, put a little dash, and as well as that, I've made sure to stay in the same x position. So for example, D is at x position 1, and the reflected D is still at x position 1. And if we wanted to, we could connect it up so we can see what the kite now looks like, just for our peace of mind. There. Yeah, that roughly looks like what we expect a kite to look like, so we're all happy. Question 7. We've got a nice big graph. We've got some bar charts at the bottom of that graph here, so these bar looking things here. And we've got some data plotted on top. And it says the graph below shows the average maximum daily temperature in Celsius and the average monthly rainfall in millimeters in Greece. Okay, so if we scroll down a little bit more, and we've got a nice little key there, so we can see that them bars are telling us the temperature, and we can see that the line with the X through that's telling us the rainfall. And we can just have a little think. Usually when they give you this data, it will make logical sense to the real world. So if we look in December, we can see there's more rainfall, the temperature's lower. We can see in August, that's when it's hottest. And goodness me, reading across from August, it's in the, is that 34 degrees? I'm just reading that by eye. You should use a ruler to read across when you're reading this graph. But it's really hot, and Greece is really hot. So okay, this graph makes sense. I understand what I'm looking at now. So if we go to part A, I, which month has the highest rainfall? So if we go back up to our graph, we've seen in our key that rainfall is marked by the line. So we're just looking for the highest point of that rainfall, which is up here. So if we now use our ruler, I'm just going to use a straight line because that's what I've got available to me. And I plot it all the way down. Where does that meet? That is November. So the highest point of the rainfall is November. Part II. Calculate the difference in average maximum daily temperature between the warmest month and the coolest month. Okay, so that's telling us to look at the bar chart and compare. We're looking for the range of temperatures. So we're looking for the highest bar chart at the bar and the lowest bar. So if we go up, I'm going to mark this in red. Keep it easy except for a question. So it's hottest in August. So I'll put little X there. I'm going to plot across using my little graph here. So this is the one I was eyeballing. Yeah, I was roughly right. So that's 34 degrees. So you can write that on there, 34 degrees. And then where's the lowest? So we're looking at December, that's quite low. Is there any lower? January. So make sure to have an eyeball each so I can see that this is 14 and you can write next to it. But if I look across here, this is actually 12 degrees. So relative to the UK, like that's still pretty pretty warm. So if we go down, we can write in. So our highest one is 34 degrees C. Our lowest one is 12 degrees C. And because we're finding the difference, I'm just taking them away from each other. So that gives us 22 degrees. So that's our range. So the warmest to the coolest temperature. Part I. Courtney wants to go on holiday to Greece. Same, to be honest. Let's go, I'm ready to go. She does not want the average maximum daily temperature to be over 30 degrees. So we'll put a little line under there because she doesn't want it to be over 30 degrees. Yeah, coming from Britain, I think that would kill me off too. And hopes for as little rain as possible. Okay. Which month would be the most suitable for Courtney to go to Greece? So if we go up, we've been doing a lot of plotting. My big lines in here, you can have, but if you used your ruler, they won't be there. So I'm just going to rub them out to make it a little easier for my eye to keep track of what I'm doing. Just getting rid of there. We don't need these. Don't need these. It's fine if you have written on yours, as long as you can keep track of what you're doing. I'm going to write this in green. So we don't want it to be higher than 30 degrees. Straight away, I'm just going to put a bar straight across on here at the temperature of 30 degrees. You can do that with your ruler. So that straight away knocks out August. It's too hot. Too hot for Courtney. July, that's too hot. Okay. So they're both too hot. We can't do these. And feel free to like cross them out there. Can't do them. Okay. Well, looking at our rain, and we want the rain to be as low as possible. So the next place where it's quite low here, it's quite low here. So the rain's a lot lower here. We're liking how low that rain's looking. So this temperature here, that is 29 degrees, so just about in our limit. So we're at 29 degrees. And the rain, that's pretty low. That's what would that be? So that's millimeters. We're reading it across. So I'm just going to put a little plot here. Reading it across here. Not that very accurately, very straight. But it's roughly like, what is that? 15 millimeters. You don't need to know this. It's just a bit of practice. So yeah, the rain's super low. So if we go back down, which month would you say is most suitable? So I'm going to go with June. It's the lowest rainfall we can get, where it's still really hot, but it's below that 30 degrees. Part B. The formula shown can be used to convert between temperatures in degrees Fahrenheit, so that's what the Americans usually use, and temperatures in degrees Celsius. That's what we usually use. You might have seen both measurements, like on your oven, for example. But we've got our little relationship there. So Fahrenheit equals 1.8 times your Celsius plus 32. They don't relate very nicely. There's not a linear relationship. On a particular day in Greece, the temperature was 25 degrees. So we've been given a number there. So we're just going to underline it so we can see it better. Use the formula to convert this temperature to degrees Fahrenheit. Okay, nice and easy. So if we substitute that in, so that's 1.8 times, so C is our temperature in Celsius, that's 25, plus 32, and that'll give our answer in Fahrenheit. Now this is not something I can do off the top of my head, but luckily this is a calculator paper. So I'm just going to do 1.8 times 25, and feel free to do it in steps. So that's 45 and then plus 32, 77. So 77 degrees Fahrenheit. That is your final answer there. Question 8. So this is just a one-parter. You've got 3 marks to get, and you've got some nice diagrams in here. Usually when you see diagrams, it suggests that you should use some sort of algebraic method. So it says, Alex and Louise buy some cereal bars and drinks at the shop. You don't know what they're doing, you don't know why. Might just be going for a nice day out. The image below shows the items that Alex and Louis bought and their total costs. So you can see that Louise bought 4 cereal bars and 4 of them cost a £5. You see that Alex bought 1 cereal bar and 3 bottles of Coke, and that is £5.60. It says assume each cereal bar is identical, so they're all the same brand, they all cost the same, and each drink is identical. Same thing again, all the same brand, they all cost the same. It says find the cost of 1 cereal bar and the cost of 1 drink. Well, straight away, diagrams, I'm not going to draw out a cereal bar every single time, so I'm just going to write cereal, oh, I've butchered that spelling, but you know what I mean, bar. In maths, you can't get points deducted for your spelling, doesn't matter, great if you're dyslexic like me, equals C, and then you're going to say your drink, you can equal it to D, you can say it's any letter that makes sense to you. And I can see, looking at Louise's, so we've got 4 lots of C. So in algebraic notation, you just put 4C equals 2, and then that's £5. And we've also, so I'm just going to put a line there to separate these equations so I can keep track. We've also got C plus 3D equals to £5.60. Well, straight away we can see, ha ha ha, we're doing algebra C. But if we look at our first equation over here, that it's only got 1 variable in there, it's only got C. So if I solve for C, if I solve to find out what just 1C is, I can just divide by 4 over here, divide by 4 over here. So C would be equal to, and as always with calculator, if you're ever worried or you can't do it in your head, just get the calculator up. Okay, so we've got our calculator up. So we're doing £5 divided by 4. So that's £1.25. Cool. So we already have part of the answer and we can write that straight at the bottom. So now for our other question, we can substitute in what we know what C is to get this to only have the variable of D. So if we do £1.25 plus 3D equals £5.60. So first of all, we're going to take away £1.25 from each side. I'm going to take away £1.25 there. So that will give us 3D equals 2. Once again, get your calculator so you don't make any mistakes, because I'm assuming you're really nervous, you're in the exam hall right now, there's too many things going on. So we're going to just do £5.60, take away £1.25, so that's £4.35, and then we're just going to divide by 3 on both sides. D equals, once again, get your calculator out. We've already got that £4.35 on our screen, so we're just going to type divide by 3. And that gives us £1.45. We can write that straight there. Question 9. Well, at a glance, straight away, you may recognise the structure of what's happening in this weekly wages box. And that's something known as a number machine, where you slot in a number at the start and you, at each step, so each place where there's this arrow, you'll do something to it. So that's the number machine is just another way of doing algebra. So if you prefer algebra, do it that way. If you prefer the number machine, do the number machine. So it says the manager of a shop calculates the wages of her staff at the end of each week. And she uses this diagram, her little number machine. So as well as that, we've got a little table here for junior sales assistant gets £10.42. So that's the hourly rate, so they get an hour. Senior sales assistant, they get like an extra like 90p on top. Fair enough. Part A. Hamza is a junior sales assistant. So straight away next to that, I can write that he gets £10.42. We know that about him. Last week, he works for 25 hours. So we're going to underline that. And had a bonus of £80. So that bonus, it doesn't matter how long he works, he must have just been doing really well the past year or the past week. He helps his managers and they just hand him over £80. It's not related to anything. And then it says, what was Hamza's total wages last week? Well, actually, our store manager has included the bonus in this little calculation, included the number of hours worked. So let's just substitute it into her little number machine. So we've got the number of hours, which is here. So we start off with 25. And then our little arrow says times the hourly rate of pay. So we know for Hamza, he's a junior sales assistant. So that's £10.42. And then you're adding on, he got a nice bonus. I wonder how often he gets bonuses. It'd be nice to have a bonus myself. But anyway, so he's got a nice bonus. And this is a calculation that we're not going to work out in our head. Straight away, calculator paper, let's use it for all it's got. So 25 times our hourly rate of 10.42. So I'm doing it in 2 steps because I find that easier. And we're going to add on our £80. So then we get 340, so £340.50. Not too bad. It's junior assistant. It's a good starting wage. Why not? Then part B. Julie is a senior sales assistant. Good for Julie. Last week, her total wage was £271, including a bonus of £64. Why are all these guys getting bonuses? Where's this money coming from? But anyway, how many hours did Julie work last week? Well, now what the question's asking for is hours. We're starting with what we had at the end in part A, and we know what the bonus is, and we know how much she's paid, so that's the £11.50 there. Let's write that down here. And we're trying to get back to the beginning. Well, if you've dealt with number machines before, you would know that you just do all of the steps that you've already done, but in reverse. So if we look back at our little number machine, you'd start with the total salary, and then the arrows, imagine them going the opposite way, and doing the opposite thing. So first of all, you'd start with your salary, and then you'd, instead of adding on a bonus, you'd take away the bonus, and then you would divide by the hourly rate to then get the number of hours. So you just following the arrows in the opposite direction and doing the opposite of what the arrows are telling you. So when it's plus, you're doing a minus, and when it's times, you're doing a divide. So we go that down with that in mind. So we're starting with 271. We're taking away our bonus, 64. And then, because we're doing this in steps, I'm going to put this in brackets because we want to do this as our first step. We want to do this first. And because of BIDNAS, the brackets come first. So we're going to take that away first, and then we're going to divide by our hourly rate, which is £11.50. So let's put that into our calculator. Let's get our calculator up. Clear the calculator. So first 271, we're taking off our nice little bonus. So that's £207. Then we're going to divide by her hourly rate, it's £11.50. So So that gives us a nice whole number of 18. And remember the units, this is 18 hours. So she's only working a part-time job. In the UK, it's usually about 40 hours, part-time jobs around, well, downwards from 30. So she might have other stuff going on, but she's a senior manager. She still gets bonuses, good for her. And we've worked out everything we need to work out. Question 10. Jared won £3,000 in a competition. Good for Jared. Part A, he spent 500. Yeah, fair enough. Like, spend it, treat yourself. And gave 37% of the remaining money to charity. Sweet. Jared's a nice guy. This was shared equally between 5 different charities. So how much did each charity receive? So let's start from the beginning. We'll do each step one at a time. So we're starting with our £3,000 that Jared initially won. So first he spent, so we'll write step 1 next to this. First he just spent 500 straight off the bat. He deserves it. He won. So that means we have £250. And then it says he gave 37% of the remaining, and that's the key word there, remaining. So that emphasizes to us that this was after he spent that £500, then he gave 37% of what remains. So 37% of this £2,500 to charity. So let's do step 2. So we want 37% of 2,500. We can do this in 2 steps. We could either divide 2,500 by 100 and then times it by 37, or the speedy step, which combines that dividing by 100 and times it by 37. You could just do 2,500 times by 0.37. So if we whack that straight, especially with it being a non-calculator paper, like, don't give yourself more work than you need. So we get our calculator up. 2,500 times 0.37. So that's £925 goes to charity. That's a lot to charity. It's a nice guy. And it says this was shared equally between, and we've got written here, 5 different charities. So this money was split between 5 different charities equally. It says how much did each charity receive? So we want to know what just one of them charities received. So he gave all this money to charity. He split it equally between 5 different charities. So to find out how much one charity received, this is our final step. This is £925. We're dividing that by 5 because it's equally divided between the 5. Once again, get your calculator. So we've already got our answer previously there, 925. So I'm just going to click divide here by 5. And that gives us, so that's £185 that each charity was given. What a lovely guy. So then it says Jared saves £600 of the initial £3,000. Yeah, that's smart thinking. He's given it to charity, he's treated itself. Some of it's going into savings. So it says what percentage of the £3,000 does Jared save? Well, we could do this. So the total here, 3,000. And out of that 3,600 is going to charity. Now we know that this we've done this as a not charity, sorry. This time he's saving it. Good for him. This fraction, if we were to solve this will just go to a decimal. So now we've made it into a fraction. So 600 out of that £3,000 is being saved. To convert it into a percentage, like the question asked, we know we just times it by 100. Nice and easy. So once again, just put it into your calculator. So clear that. So clear that. So 600 divided by 3000. There we go, we can see it's 0.2 in decimal. Then we're going to times it by 100 to get it in percentage, and that's 20%. Question 11. Now this is all algebra. It's giving your brain a rest from clicking away on that calculator. It's just checking that you know the basics of mathematical reasoning. So first, part A, simplify each of the following. So you've got A plus 7B plus 5A minus 9B. And we all know that we're going to gather our B's together, so the variables that are the same. And I'm going to write in red, then we're going to gather our A's together. So feel free to just rewrite this out straight away before you even start gathering. So I'm going to put my A's on one end, because you should know about arithmetic, that it doesn't matter what order you write all of these terms in, it'll equal the same thing. So we've got our A's on one side now, and then we're going to add 7B and then minus 9B. Okay, so now A plus 5A, that's just 6A, nice and easy. And then 7B minus 9B, well, that would be minus 2B. And that's it. You've done all your steps, you've got 2 marks, you've done it in seconds, and everyone's happy. So next it goes 6W divided by 2W. Well, how many lots of 2W is in 6W? You may think it's a bit of a trick question because it may seem too simple, but it's just 3. The final answer is 3. And you can see that if you write this as a fraction, so you've got your 6W, ooh, that's a wonky W, over 2W, straight away, ooh, I'll cross them out in red to make it a little clearer, your W's are gone. So then it just becomes 6 divided by 2, which is just 3. That's nice and easy. Cool. So moving on to the next question, this sort of question where you're converting things into algebra comes up quite a lot. They'll either ask you, like here, explicitly to do it, you get 2 marks, or like you've seen in previous questions, like we did with the cereal bars and the bottles. Some questions it's just easier to use algebra, so you may just start using it yourself anyway. So let's start reading. Amanda buys 5 bags of apples, and each bag contained n apples. Okay, well, it's already giving you the variable it wants you to use. It wants you to use this n. So we know that Amanda initially has 5 lots of n. That's what she has. And then she says she gives 2 apples from each bag. So each bag, she gives away 2 apples, and this is where the trick comes in. So this is write an expression for the total number of apples Amanda has left. Well, initially she has 5n, so she has 5 lots of n, and I'm going to put in this bracket 5 lots of n. If she's giving away 2 apples from each bag, then that would be 5 times 2, because there's 5 bags. So how would we write that with our brackets? Well, you could just do 5, and then the brackets implies times. So 5, you've got your brackets, and the number of apples she has initially is n, but then with each bag she's taking away 2. So that final answer would be 5 bracket n minus 2. Or if you wanted, you could write down, so that's like the simplest form that's been factorized. You could also have, okay, well, we have 5n initially, and then each bag, so we know that she's got 5 bags, so minus 5 times 2. So you could also have 5n minus 10 if you wanted to, and you'll notice that that's just the brackets expanded. It's either or, it's however your brain likes to deal with this best. Question 12. Now we've got a bunch of information, but we're just going to take each line like one at a time. So the Cowell family are planning a holiday to Spain for 7 days. Sounds nice. I might underline that 7 days because that's a number that seems like it could be relevant. They can either pay for a package deal, okay, so either or, so that's option 1, or pay for return flights, accommodation and food separately. Okay, that might be a situation that you guys have dealt with before when you're planning your holidays, or you might have like heard your parents dealing with it, whatever. And then we've got the information below for the package deals. That's our number 1 there. That's our number 2 there. For the package deal, everything included, 7 days, family of 4. It's just that amount. Okay, we don't need to do any more calculations. Paying separately. Let's see. Return flights, accommodation, and food are free for children under 2 years old. That's an interesting bit of information there that they've added. So we've got return flights each person, accommodation, we've got food, and that's for 7 days, so we don't need to multiply that. That's for the whole 7 days. Okay. On the holiday, there will be 2 adults and 2 children. Okay. So if we have a look here. So yeah, that's fine. Everything's done with package deal. That's the final amount. And it says the children are aged 8 and 1 year old. So we'll put an arrow there. We just read that if you're under 2, that's free. So they each require return flights, accommodation, and food. That's fine. The Cowell family wishes to choose the cheaper option. Well, yeah, that makes sense in this economy. Yes. So it says, which option should they choose? So we already know all of the prices for the package deal. We don't need to do any more calculations. What we're trying to work out is how much it'd cost if they did everything separately. So we've got 2 adults and 2 children. Return flights, accommodation, food are free for children under 2. So that 1-year-old child, absolutely everything is free. So actually, we're only calculating this for 3 people, the 2 adults and the 1 8-year-old. So you can write that underneath. So you could say 1 year old, free, 2 adult plus 8 year old. Okay, so that's, you can say 3 people. Okay, so we need everything for 3 people. Let's have a look. So first of all, it's return flights. That's a flight there and a flight back. So we're going to do, so all right, flight. That's just going to be 3 times our cost per person, which we can see is $3.52. And then if we look at our accommodation, it's £43 per person per day. So if I put a com here, so per person, so there's 3 people times the cost, that's per day, 43, and they're there for 7 days. So that's per day, so we're going to do 7 days. Okay, and the final cost that we're going to add on is food is $85 per person for the full 7 days. So we don't need to multiply by 7 that time. We're just going to do 3 times that £84. Oh, £85, sorry. Yep. Cool. And then the final amount would just be all of these added up. Do that. Flights, accom, and food. So let's just work them out all separately. Just plugging everything into our nice little calculator. So starting off, to clear that, we've got 3 times 352, £1,056. Then we've got 3 times 85, £255. Now, a slightly longer calculation, we've got 3 times £43 per day times 7 days. So that's £903. And then the final step would just be adding all of this up. get our calculator. So we've got 1056 plus 903 plus our 255, so 2214. And you can even write next to it, that's pay separate. So if we now scroll back up and just double check how much the package deal was, so that's £2,300. If I write next to it to pay separately, that's 2,214. So we can see that that amount here is about, you're gonna save about 86 quid. But 86 quid, all of that matters. The parents can use that to buy toys for their kids. They can use it to go to the bar, whatever. You want the cheaper deal. And that's what they've said. So now we've shown that by paying separately, that's cheaper. That's like cheaper by 86 quid. Yeah, they're going to pay separately. Question 13. You can see straight away in the top right-hand corner, there's a little graphic of someone flipping coins. So that tells us this is probably a probability question. So part A says 3 fair coins thrown at the same time, where fair coins means it's a 50-50 chance. It's either going to be heads or tails. Part I says complete the table to list all the different possible outcomes. So how all of them 3 coins going to be orientated once they're flipped. And it says the first row has been completed for you. So in the first row, it shows that all the coins are heads. So now we can just go through and think about all the different combinations we could have of heads and tails. So to start off with, I'm just going to have that one of the coins is tails. So that could be the first coin is tails. Could be the second coin is tails. Or it could be the third coin is tails. Okay, well, what if 2 of the coins are tails? So it could be the first 2 coins. Could be the last 2 coins. Or it could be the first coin and the last coin. And then the last combination you could have is just everything being tails. How many have we got? We've got 1, 2, 3, 4, 5, 6, 7, 8 different combinations. And though you don't need to know this, what I can do in my head to check this is you've got 2 possible outcomes, heads and tails. You've got 3 different combinations of these 2 different outcomes from all these coins here. So the number of combinations you will get is the number of possible outcomes, which is 2. And then the number of items, like the coins, that can have these 2 outcomes. So that gives us 8. So we're looking for 8 combinations. We've got 8 there. We're happy. So part B says when 4 fair coins, so we've got 4 now. You can write in a 4 there, so you know, are thrown at the same time, the probability that the outcome is 2 heads and 2 tails is 0.375. If the same 4 coins are thrown 136 times, how many times would you expect to get the outcome 2 heads and 2 tails? Now this one's a nice easy one if you know what to do with these numbers, because you've been given the number of times that you're flipping the 4 coins, 136, and you've given the probability that it's going to be 2 heads and 2 tails. So all you would do is times the number of times you've done it, so 136, times that probability, 0.375. Now I can't do that in my head, so I'm just going to get my nice little calculator, move that across here, and let's have a go. So 136 times 0.375. That gives us a nice whole number of 51. So 51 times out of the 136, you will get 2 heads, 2 tails. Question 14. And we can see it's A, so there's going to be another part after this. So you've got a bunch of information. So as we go through, we're just going to underline things. So the amount of electricity and gas used in a home is measured in units. In the first week of May, the Singh family uses, here's our first number, 56 units of electricity and 245 units of gas. So we'll get the electricity there, I'll get the gas there. The cost per unit of electricity is 32p. The total cost for the units of electricity and gas the Singh family used in the first week of May was £39.97. What is the cost of 1 unit of gas? Well, we've previously said this, where some of the questions, like that's a lot of words, we don't want to be working with words, this is maths. You can convert it to algebra and then work with that. So if we have our cost of the units of electricity and gas, so this £39 is formed of the electricity and the gas. Well, we know that for electricity, they used 56 units. And now I'm going to use a small e to show that's units of electricity. Plus, for the gas, they had 245 units. I'm going to use that small g. What else have we been told? Well, we know the cost per unit, so this small e is 32p. So I can write 56 times 32p plus 245 g equals this amount here. Now, it comes down to, you've got an algebraic equation, and all we're going to try and do now is solve for this g here. So the first thing we can do, we do the exact same to each side, is we're going to take away over here this 56 times 32p. We're going to take it from this side as well, but that'll just cancel out, times 32p. Now, to make this easier, before we do this calculation, the minus 56 times 32p, 32p is the same as if you'd written 0.32 pounds. So now we're just going to whip out our calculator, move that here so we can see our calculation, and we're going to do £39.97 minus, and you don't actually need to use brackets because with BIDMAS you're going to do the multiplication before you do that minusing, but we're just going to put the brackets for our own peace of mind. So that's 36 times as 0.32 pounds. Converts, that gives us £22 and 5 pence. Which is equal to 245 gas units. So now we just need to divide each side by 245 to get what 1g is worth. So straight back into our calculator. So with our calculator, we are going to do £22 and 5 pence divided by 245. Which gives us, so that's 0.09 pounds. But if we converted that to pence, we could leave it as pounds if you wanted to. If we convert that to pence, that is just 9 pence. Part B. The Singh family are calculating their electricity bill for the 30 days of June. They use 210 units of electricity in June. The cost per unit of electricity is 32 pence. They pay a fixed charge of 28p per day. VAT at 5% is added to the total of these costs. Calculate the total cost of the single family's electricity bill for June. So that's a lot of information that they have just given you in one go. So we're going to take it one step at a time. We're going to work back from all this stuff that we've just been given and start underlining things. So electricity bill for 30 days of June. So it's 30 days. They use, so in total for June, they have 210 units of electricity. It's the same charge we were told before, so it's 32p for all of them, and they pay a fixed charge of 28p per day. So when we're doing these maths questions, Eduqas, AQA, Edexcel, any GCSE maths provider love to do this example question of a standing rate charge. Now, all that means is even if you use no electricity that day, just for having that switch switched on so you can get electricity, the electric company is charging you 28p. So say for 1 day of electricity, we could write 1 day. You would have the units that you use in that day, we'll put U times that cost per unit, so that's 32p, plus your standing charge, so that's your 28p. And I've just written that straight into algebra to show you. But if we did it for 30 days, say, 30 days, so we don't know the number of units they used in 1 day. We've been given for the whole of June, they've used 210 units. So that'll be times 32p. That'll be plus, well, it's for 30 days, so 30 lots of 28p. So plus 30 times 28p. So that's how much they've been charged for the units they've used and the standing charge. So let's just double check the last question. So VAT at 5% is added to the total of these costs. So this is the last step. We'll do this last. Okay? So we'll work out this first. We'll work out how much we're being charged for the time and for the standing charge. We've got our calculation. As always, straight to the calculator. For that, we're going to do units times. So once again, it's easier if we just convert that straight into pounds. We're going to do 0.32 plus 30 times 0.28. That gives us £75.60. So if we hadn't done that 0.32 and 0.28, we would have had that in pence and had to convert back, or you could have just left it in pence if you wanted to, but a little unwieldy if you get a bill all in pence. So now we're on to the last step. There's 5 marks to get. You've probably got 4 of them marks. You know how much it costs in total. It's just that VAT at 5% is added to the total of these costs. So that means 5% of this value here is added on again afterwards. So it'll be plus 5% of 75.60. Well, there's actually a really fast and easy way we can do this. You could either work backwards, so you could find out what 1% of £75.60 is by dividing by 100, and then you can times by 5 to get 5%, and then add 75.60 plus that 5%. That's an easy way to do it. But the fastest way to do it, and we always like a lazy method, you can do 75.60 times 1.05. Now, timesing it by 1 will give you 100%. Timesing, if you just wanted to get just the 5% on its own, you could times it by 0.05. That will give you the 5%. Just imagine that you can combining your 2 steps, so dividing by 100, timesing by 5. If you combine then steps, you could just times the whole amount by 0.05. So instead of working out, so you've got your 100% there, and then working out your 5% and adding them together, all you are doing is doing all of them steps in one step by just timesing by 1.05. So we put that straight into our calculator. So we've already got the initial amount there, so we're just going to times by 0.05. That is £79.38. And that's your final amount. That's all your 5 marks. So it's just that last VAT step and knowing what all of this means. Question 15. Rhiannon cycled from her home to a park. She cycled 15 miles along a straight road. That's quite far to cycle. That takes like an hour or so. Oh, I guess we'll find out from this graph. And the graph shows her journey. So we've got distance from Rhiannon's home in miles on our y-axis. So that's over here. So I'll just write on your y-axis. And then your x-axis is your time. So part A asks you, on her journey to the park, Rhiannon had a puncture. How long did Rhiannon stop to repair the puncture? That sucks for Rhiannon. She just wants to go to a park. Her bike's punctured. And what it's telling you there is that she had to stop, which means she's not making any progress. Her distance won't be changing. So now if we look at our graph, where is the distance not changing? Well, we assume at the top of the graph, so let's say where this graph ends, we know that here she's at the park. She made it to the park. And the only other plateau that you see on this graph, so where it goes flat, is here. So if you look here, even the time's passing, so she's waiting. Let's find out. So she sets off again at 10. And when she stops is, and this will be a lot easier when you have your ruler, but I'm just using my little app here. So I can see that that's 2 little notches past 9:30, and then that goes up to 10. So in total between 9:30 and 10, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 notches. If each one of these notches, there's 30 minutes, and there's 10 notches, that means each of these little notches is worth 3 minutes. And if we're 2 notches over from 9:30, that's 6 minutes past 9:30. So this start bit here is 0936, which means she was stopped between 9:36 and 10. So she was stopped for 24 minutes. Part B. Rhiannon was, on average, travelling faster before she had her puncture than after she had her puncture. Without calculating any speeds, explain how you can tell this from the graph. So we'll do this in green, so don't get confused with the previous question. Her puncture, she had it here, this red spot. So this is before the puncture here, and this is after the puncture. What can we tell from what we see? Well, we can see that this line before is steeper. We can see in half an hour she's travelled, what is that? Almost 10 miles. She's travelled quite far. Whereas afterwards, that's in about an hour. We don't need to calculate anything, because it's told us we don't need to. But it's just so we can, for our own peace of mind. So in that hour, she's then instead travelled like 5 miles. She's not travelling anywhere near as fast. So the difference is the steepness of the graph. The steeper of the graph, the faster she is travelling. So we just need to write that in words. So before the puncture, she is faster, which is shown by the graph being steeper. Part C. Rhiannon left the park at 11:30 and cycled back along the same road to a friend's house that is 5 miles from her house. So she started at her house in our graph. So at that 0 point, that's her house. So we're going to end up about 5 miles from that 0 point. So 5 miles higher on that y-axis. And it says this journey takes 45 minutes. So we're going to assume that she's traveling at the same speed. So she sets at 11:30. She travels to a house that's about 5 miles away from her house, and it takes her 45 minutes. So we go back to our graph. So 11:30, our starting point. We'll do this in blue. Our starting point is up here, so it's where the graph left off. It's going to take 45 minutes. So looking on this time axis down here. So it's the next notch, that's half an hour, and then we want to go to the halfway point, which is about here. And we know that the friend's house is 5 miles to the 0 point of that line. That's where her house is, but her friend's house is up here. So now we just need to join these points. So she sets off at 11:30. Travels, we're assuming like at a linear speed, she's going the same speed all the way back. It takes her 45 minutes to get her, and the friend's house is 5 miles away. That's all you need to do for that question. So then II says calculate the average speed of Rhiannon's journey from the park to her friend's house. Okay, well we already know that it only took 45 minutes. So now we know, or you should know, speed equals distance divided by time. Sadly, how to calculate speed is not given on the formula sheet. But you might know the units of speed, for example, miles per hour or kilometers per hour, meters per second. So it's some sort of distance over time. And the units can tell you a lot about what the equation's actually doing, because that knowing the units speed is distance over time, we can write that speed. That actually also gives us the equation for speed. So it's just going to be our distance, how far we've travelled, over the time it takes to get there. That'll give us the speed. So we know our time, because it told us in the previous question, is 45 minutes. So then if we go back and have a look how far she travelled, that park is 15 miles away, and she travels to a friend's house that's 5 miles from her house. She travels 10 miles. So we've got our distance here. So that's 10 miles. And it wants the answer in miles per hour. But we know that 45, that's 3/4 of an hour, or you can write that as 0.75 hours. And we know that because there's 60 minutes in an hour. So if you were to split an hour into 4, you've got 15 minutes, 30, 45, 60, that's the hour. So if you've got 45, that's 3 lots of 15, you've got 3 out of the 4, so 0.75 hours. So now all we need to do is 10, which is the distance, divided by 0.75. And you don't need to know that off the top of your head. As always, we can just use our calculator. So let's do 10 divided by 0.75. And that gives us 13.3. And all that dot above the 3 meant was recurring. But if we just do it to 1 decimal place, rounding, that would just be 13.3 miles per hour. And just double checking the mark scheme, it actually says here that you can leave that as an improper fraction. If you wanted to, you could just leave that as 40 over 3 miles per hour. They've been quite nice with this question. Question 16. So I've already got my protractor out, as you can see on the left hand side, but you can see just from the picture, we've got some little arrows facing north. We've got what looks like a map, and it says at the top, this is a map of a holiday park. So straight to part A, it says measure and write down the bearing. So we know that it's going to be using a protractor, like we were saying, looking at the front of the sheet. In the list of equipment you need, it does mention a protractor. And it says the bearing of the reception from the park entrance. So that means that we're going to start from this park entrance here. So this is our start. We'll put a little S here. And our end point is this reception up here. End. So if we draw a little line there, just so we can see we're going from here to here, and we'll put in a little arrow top so we know which direction we're going. So as you should know, with doing bearings, you start facing north. So that's 0 degrees north. And you follow around clockwise. So starting from north, you start swiveling around clockwise until you get to the degrees angle of this line here. Now, a lot of traditional protractors will be like the one that I've got here on the screen. If I click on that to move it over, it's a little bit unclear to see with white on white, but we'll work with it. So doing that, if you have a full 360 protractor, good for you. That's nice and easy. You can just read around till you get to that angle line there, the red line, and see what it is. But because right now we don't have that, what you're going to do is starting at 0, or you could also call this 0 mark 360, because once you've gone around your whole 360 degrees, you get back to the 0 position. And because it's bearing to the left, what you could do is actually count down from 360. So if you know what this angle here, so between the north line to the red line is, then you should take that away from 360. So let's read what it is. Now we've used quite a thick line, but the benefit of this is it emphasizes the fact that in the mark scheme, it's usually plus or minus 2%, which with our thick line, yeah, it's about plus or minus 2%. So we can read off here. So from 90, it goes down to about 60, 61, which means that this gap here, going from 90 to 61, we can work it out by doing 90 minus 61, which is about 29 degrees. So we know this gap here is 29 degrees, but because you have to do the clockwise, we can then figure out what the full bearing is, and I'll switch colours now to write down here, is 360 minus that little angle there, so the 29 degrees. So we're going to get about, what is that? You can always put it in your calculator, remember, but we're just going to do it in our head. So that's 331 degrees. Now, if I just go and quickly check I can see that, yes, plus or minus 2% of 330, which is what we've got. That's perfectly fine. So that has gotten us our marks. So if we zoom back out and see what the next question is. Part B. Amir is camping at the holiday park. His tent is on bearing 25 degrees from the park entrance and 280 degrees from the park exit. Mark with a T the position of Amir's tent on the map. Okay, so let's go up to the map and we'll take everything one step at a time. We're going to put our little compass here back on. And we want 25 degrees. So because the top of the compass is 90, to get 25 degrees, we want to go to looking at the top big numbers, 25 less than 90. So that would be 265, so about there. And we can put a little line in there. So we'll go back to red, draw a little line along there. So now, looking at the question again, it says it's 280 degrees from the park exit. So now, we're going to start at the park exit. So here's our start this time. We're going to put in our little protractor, and we want it 280 degrees. So having to think how we did it the first time around, when it's 280 degrees, that would be 80 degrees left of the north, because we know north can be 0 or 360. So saying it's 360, we could do 80 degrees left of that north. So let's put in the line straight away. So 80 degrees left, that would be here. And I know that because my protractor to the left, there's only 90 degrees. So if it's 80 degrees to the left, that means it'll be just 10 degrees on this little bit here. And I've just drawn a line until they both cross. I've done that because if I know that it's 80 degrees to the left of that, I know it's 25 degrees from there, I can draw an X where it overlines, or overlaps rather, that is exactly where the tent will be. So now, X marks the spot, and we can put a T. That is 3 marks. And if we look at the mark scheme, yep, it says 2 overlapping lines. Once again, we've got a tolerance of plus of minus 2%. And just to get 1 mark, if you just put 1 line, you're like, okay, well, I know how to do the first one, don't know how to do the second one, you've already got some marks. Question 17. We can see straight away we're doing a nice Venn diagram question. So it says the universal set shown by eta, so that's the weird backwards 3 there, contains the numbers 4, 9, 12, 18, 23, 32, 50, 64, and 72. It says that S, so that circle on the left, is the set of square numbers. So all the square numbers have got to go in there. And F is the set of factors of 36. So we need to find out what factors go into 36. So we've got to put this information. So we know the numbers that we've got to put in are here. We know that in S it's going to be all the squared numbers. In F it's going to be all the factors of 36. And where they overlap is where the factors of 36 and square numbers are both going to be. So let's first find the factors of 36. So let's do 1 and 36 to start with. You could have 2 and 18. You could have 3 and 12. You could have 4 and 9. Is there anything else that we're forgetting? Can't have 5. Can't have 7. I believe that's all of them. So now we just need to start circling off. So we'll do this in red to make it easy. You don't have to do it in red if you don't want to. You have a pencil and you have a pen in your exam. Use them as you will. So we know that 9 is a square number, 4 is a square number. So what's defining the square number here is, for example, 2 times 2 is 4. So it's 2 numbers that are the same times together, and then the product, that's the square number. So the second one, 3 times 3 is 9. So we know that is. Is there any others? Well, there's actually 36. Because if you do 6 times 6, that gives you 36. But the others from inspection, they're not. So now, okay, we've got all these factors of 36. we've got this list of numbers and we need to find which ones are square numbers, which ones are factors of 36. So we'll start by putting a circle around the ones that are square. So we've got this one, 23, 32, 50, 64 squared. So 64 is 8 times 8. And that is it. Okay, so that's all the squared numbers. Now we're going to put some blue on the ones that are also factors. So we've already shown, we know 4 is, we know 9 is, we see 12 is, 18 is, don't have 23, 32, nope, 50, nope, 72, nope. Okay, so all the ones that, so if I just get rid of that bottom line to make it a little bit clearer. So all the ones that are underlined and have a circle, they will go in the middle. So we're going to put 4 and 9 in there. All the numbers that are just underlined in blue, they will go in the factors, they'll go in F. So we've got 12 and 18. The other square numbers, so we've got 64, so only a square number. And everything else that doesn't go inside these circles, we're going to have 23, 32, 50, and 72. And that is the Venn diagram complete. Part B. A number is selected at random from the universal set. So that's just this big list of numbers up here. Find the probability that the number selected is a factor of 36, but not a square number. Okay, so we want it to be a factor of 36. So that means that we're looking inside, I'll get a nice green here, looking inside this circle at the moment, but then we don't want it to be, so it needs to not be a square number. So now I'm going to rub out this bit because we don't want to include this middle bit. We don't want that. So now what we've got in there is just 2 numbers. So we've got 2 numbers out of a set of, well, how many is there? 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's 9 numbers there. So 2 out of the 9 numbers are factors of 36, but not a square number. And you can just leave it as that. That's finished. That's fine. Question 18. So looking just what we see straight away, we've got a grid, we've got 2 different shapes. They vaguely look the same, but they look like they've been moved. So I'm guessing we're going to be doing translations. It says the grid below shows triangle A and B. Cool, I see A and B. So now if we go to part A, describe fully the single transformation that maps triangle A into triangle B. So let's have a look. It looks like triangle A, just by observation, triangle A has been rotated like this until it reaches this point here. So then we just need to know what the center of rotation would be. So we can see it's a rotation. We can check it's the same size. So that bottom bit's 4 there, that bottom bit's 4 there. It's going from this point to this point. It's 3 across, 1 up, 3 across, 1 up. So it's not been stretched or anything. It's not been expanded or made to grow. It's just rotating. And we can see that this point that's originally at the top is now at the side. So that is a rotation of 90 degrees. So now we just need to know where the center of rotation is. So if we have a little bit of a look, relative, we'll start with 0, relative to 0, 0, we go across 2, up 1 to get to there. Relative to 0, 0 here, we go down 2, across 1. that tells us that actually the center of our rotation is this 0, 0, which you can test, of course, by, if you have some tracing paper, you can trace over the top and then rotate that shape 90 degrees to find that. But you can just do it by observation, especially after you've done this, done these sort of questions quite a lot, as I have. As I say, first thing I see, shapes look the same, they've not grown or shrank, looks like they've just rotated, which I can see 90 degrees, and I've just sort of looked, okay, well, I'm going to just arbitrarily choose this. Is it the same distance? Yeah, it's about the same distance, so that's the center. So you would then write 90-degree rotation about, so that means like moving around 0.00. And you should say which direction that rotation is, because I've just said 90 degrees rotation. That could be anti-clockwise, clockwise, but we could see it's gone to the right, so that is clockwise, so the same direction as a clock. So if you don't have that clockwise in there, I believe, yeah, you'd only get 1 mark. Moving on to part B, it says translate triangle A using the vector -3 and 2, and then label it C. So our vector is telling us that it's going to move -3 in the X direction, then 2 in the Y direction. So it's not going to rotate, it's not going to grow or shrink in size. We're just, as if we were picking up the triangle, moving it 3 to the left, or -3 on the x-axis, and then 2 up, or 2 the positive direction on the y-axis. So let's do it point by point. So we start with this point here, we're going to go 3 to the left, 1, 2, 3, and then we're going to go 2 up, 1, 2. So that's our new point. So now I'll choose a different colour so I don't get confused. So we'll do this point. We're going to go 1, 2, 3, 1, 2. So that's the new point. And then we'll do this in green. So we're starting here. We're going to go 1, 2, 3, and 1, 2. So that's the new point. Now let's connect these all with a nice line. So this point to our new point, this point to our new point, this point to our new point. Okay, so we've drawn the shape, and always double check if it's, yep, it's asked you to label it C. And it says that just in case you make a mistake, you draw a nice shape, but it's in the wrong location, and you go, oh God, put the wrong shape. You draw the right shape, and then they'll know which one to pick, depending on which one has C in it. If you forget the C, they may give you the mark if they're feeling nice, but they have told you to label it C. And looking at the mark scheme, they've even been quite nice in saying that if you misread and you translated B correctly, you would still get 1 mark. So fair enough, they want to be nice. Question 19. Shortbread biscuits are made from flour, butter, and sugar, and their masses are in the ratio 4, 3, and 2, respectively. Part A says, what fraction of a shortbread biscuit is made up of sugar? It's a very common question, and people always make the mistakes of not doing this very first step. So with ratios, you have 4 parts of something, you've got 3 parts of another thing, you've got 2 parts of something else. But in total, how many parts you have is just all these numbers added up. So 4 plus 3 plus 2. So that is just 9. So you can even put that in there, plus 3 plus 2. So then if you're doing a fraction, what fraction of a shortbread biscuit is made up of sugar? Well, in that ratio, the sugar is 2. Because when it says respectively, it means in the exact same order as they initially said it. So that means 2 parts out of the total 9 parts are sugar. And that's it. You've got your fraction. A lot of people will forget to add up the 9 and will just put a random number from that ratio list. Don't fall for that mistake. You know how to convert ratios and fractions. You've got it. So now we'll move on to the next. Part B. 1,400 grams of flour is used to make a batch of shortbread biscuits. How many grams of butter is used for this batch of shortbread biscuits? So you've got 1,400 grams of flour. So that flour, if we look at our ratio, and we don't need to care about the sugar now, we are only looking at the ratio of the flour to the butter. So flour, so F2B, that's 4 to 3. So for every 4 parts of flour, we need 3 parts of butter. Okay, well, how do we figure out the weight of butter, you may be asking? Well, if we have 1,400 grams of flour, and that makes up 4 parts, well, how much is 1 part worth? Well, you just divide this by 4. So we'll get out our handy calculator. We're not going to do any more brain power than we need. We need to save our brain for the remaining questions. So we're going to do 1400 divided by 4. So 350 grams is 1 part. So 350 grams, that's 1 part. Okay, well, how many parts of butter do we have? We have 3. So we need 3 times 1 part. So butter will be equal to 3 times 350. And you can do this with your calculator. Thankfully, I can do this one in my head, and I can write it down and be quite chuffed with myself. So 2 times 350, I know that's 700. And then you're just going to add another 350 onto that. So that gets you to 1,050 grams of butter. Question 20. We've got a nice picture of a car here. And we're going to enter a question that examiners seem to love, which is about interest and loss of interest and so on and so forth. So Lucy bought a car 9 years ago for 12,250. And okay, it's not going to be worth that now. And that's what you're going to figure out. So the car depreciated. So what depreciated means is went down in value by 18% in the first year. In each of the following years, her car depreciated by 15% of its previous year's value. By how much has the car decreased in value in the last 9 years? Okay, so we can start drawing a little diagram. There's lots of words there. We're not a fan of words. So we've got, let's see. So we've got our initial amount, and we can even do it in steps. So we've got our initial amount. We buy it for 12,250. So that's year 0. Now, first year, it decreases by 18. So we can write that there, 18%. Initially, it's 100%. It's gone down 18%, so it's about 82% of its original value. So we can work out 82% of its original value using a trick we used earlier in the paper, because you could divide by 100 and then times by 82, or you can combine them 2 steps by just doing times 0.82. So that's the original one there. So let's get our calculator out, because we cannot do that in our brains. Cool, we've got a nice calculator. Oh, I'll make that a little bit smaller. There we go. So we're going to do 0.82 times our original number, 12,250. So after the second year, wow, it's gone down quite a lot, hasn't it? It's now 10,045 quid. So that's in, after the first year of owning it, it's now 10,045 quid. Okay, so that's year 1, that's year 0, but there's 9 more years to go. So you're like, okay, oh god, I have to repeat this. What is that? 8 more times? I have to do this and this and this and this. But if you actually think about the calculation that you're going to be doing over and over again, now you've got this number. It's gone down 18%. From this number to get to the next one, so now you're going to go down 15%. So you're going to do your handy little calculation. So if I put this here, it will be times by. So if it's going down 15%, it's going to £85. That's 0.85. So you times that number by 0.85. Well, then in year, so that's year 2. But then in year 3, you would just take the number from year 2 and then times it by 0.85. And then in year 4 and so on and so forth, you just keep timesing it by 0.85 until you get to that 9 years. So you could actually do this in one step. So you could do this 10,045 quid times by 0.85. And rather than writing out 0.85, because you are just timesing it by 0.85 8 times, instead we're going to just do a little 8 here, which means to the power of 8. That's exactly the same. It's nice math notation, so we don't need to keep writing it out. So now we're going to just plug that into our calculator, nice and easy. So we've got our 10,045 quid, and we're going to times it by 0.85, and then our power button is, so I went to this one here. Can I make this a bit bigger? Yeah, a little bit bigger there. So I used this number here, so it's an X, and then it's got just a blank cube, and that's because that blank cube you could put in any power. You can put in your cubes, you can put into the power of 4, but in this case we were doing the power of 8 because it's times in 8 times. So now we've got, whoa, that number. You don't really have like 0.1 pence, so we're just going to do to the second decimal place there. So we're going to say it's 273.7 and then 7 because we've just rounded, and then that's pounds. But what you might not know is you've only got 3 out of the 4 marks at that point, because you've not actually answered the question. It says by how much has the car decreased in value in the last 9 years. So what you've just worked out there is what the car's currently worth. So to find out how much it's decreased, you're just going to do your original value, that 12,250, minus your new value. Once again, you're going to get out the calculator, and we're going to keep this number on here, so we're not doing too much rounding. So now we're going to go 12,250 minus, and if you click that answer button, it'll be the answer that you previously had on the calculator, because you want to be lazy, you don't want to type it out again. Equals, so that's 9512.83, and all we've done from the calculator is we've just rounded it once again to 2 decimal place to account for pence not being any smaller than that, really. So in this, I'm looking at the mark scheme, and there is an emphasis on rounding. This answer, that will get you marks. If you round a little bit differently, or if you rounded in the previous step and then you've done this final step, you'll still get your marks, but you might lose a mark if you rounded too much. Question 21. Regan caught 70 fish on a fishing trip. A lot of fish. He measured the length of each of the fish in centimetres. Bragged to his friends. Maybe he's a scientist. Who knows? The table shows his results. So we've got some pooled or like box data. So that means that with the lengths, rather than stating the exact lengths and plotting it, he said if it's between 60 centimeters and 65 centimeters, I'm just going to tally up till he got to, for example, in this case, 19 fish. And he's done that with all these different ranges. So it says calculate an estimate for the mean length of these fish. So if we're finding the mean, because we've got this box data here, we want to use the midpoint. Because if we use the lower end of the numbers, then our estimate for the mean would be too low. If we use the higher end of the numbers, the estimate for mean would be too high. So if we take the exact middle, that should give us a good mean estimate. So we do 62.5, 67.5, 72.5, 77.5, and 82.5. So that's the midpoint, because these numbers are exactly between the lower estimate there, 60, and the higher estimate, 65. To calculate the mean, we've got the weighting of the number of fish, we know the total number of fish. Because we know that there's 70 fish, you could do the mean of the number of fish by doing like 19 plus 17 plus 23 plus 10 plus blah blah, divided by 7 for the different pools of fish. But because we're trying to find the lengths, what we're going to do instead is we're going to do these midpoints, 62.5, and we're going to times that by 19, so the number of fish in each case. So then we're going to do plus 67.5 times 17 plus 72.5 times 23 plus, I'm just going to the next line because I've run out of room, plus 77.5 times 10 plus, and I won't bother doing the times 1, but 1 times 82.5 is just 82.5. And all of these, to find the mean, we're going to divide by 70. So we can start just plugging that into our calculator, and I'm going to do the divide by 70 afterwards so we don't make any mistakes. Something else you could do each one of these multiplications separately and then add them up. But if you're feeling confident with your calculator, just put them straight in. So we'll get our calculator up, get rid of the previous thing we were doing. Let's just start typing away. Okay, so we've put it all in, and you can use your calculator, just tap in left and right, just to double check what you've put in, make sure that you're all happy. So we're going to click equals 860. So now we just need to divide that by 70. So going back to our calculator, we're going to do divided. So if you just go to divide, the answer's already in there, divided by 70. That gives us 69 point, and we'll round to, let's say, 1 decimal place. That seems sensible. So round into that 1 decimal place, and the unit is centimeters. Part B. Regan thinks the median length of the fish is in group 70 to 75. Is Regan correct? So if we look up at our table, we see group 70 to 75. Yes, that has the highest number of fish. However, what the median is the exact middle point of all them 70 fish. So we've got 70 fish, and we want to know the value of that 35th fish. So if we go up and go, okay, so there's initially 19, and then in the next group on, so if you do 19 plus 17, you would get to 36, which means the 35th fish actually lies in this group here, in 65 to 70. So we go down, so it's a little bit of a trick question, it's trying to catch you out. So you can say no, because you know 35th lies in 60 to 70 range. .35, so that's the median. Question 22. Jan has a large piece of card. Cool. The card has a width of 60 centimeters and a length of 96 centimeters. Got a little diagram of the card there. She uses a machine to cut identical circles out of the card. Okay, Jan's doing arts and crafts. Each circle has a radius of 6 centimeters and they've been nice and kind. And on that little diagram, they've actually shown you where the radius is. And then you've got a little diagram not to scale. Jan has cut 5 circles as shown on the diagram above. She continues in this way to cut as many circles as possible from the card. What is the maximum number of circles Jan can cut out of the card? Let's have a look. So if it's 96 centimeters long, let's do how many we can cut in this direction first. Okay. So if it's 96 centimeters long and across here, so the total width of this circle is 2 times the radius, so that we're getting the diameter. So it's 2 times 6 centimeters, so that's 12 centimeters. Then what we're going to do is 96 centimeters divided by 12 centimeters. So in that total length, how many of these circles can we fit in? So let's get our handy dandy calculator out. Let's do 96 divided by 12. So this here gives us 8. So you can have 8 circles. You can put the unit there so you know what it is. 8 circles across. Okay, we're working downwards. Now we want to know how many lots of 12 are in 60. 12, you might know this off the top of your head, as I do. That's just 5 circles. Okay, they've been really nice with this one. This has all come out as whole numbers. So that means you're going to have 5 rows, so 5 rows of 8 circles. Because you can go for 5 down, go 8 across. Imagine that card. If we go up, this is going to be a terrible diagram, but imagine that card like absolutely filled with circles all the way across. 2, 3, 4, 5, 6, 7, 8. And we can have 5 going up, so it's 1, 2, 3, 4, 5. And imagine the whole thing filled with circles. So in total, we'll have 5 times 8, which is 40. So 40 is the maximum number of circles. And feel free to write circles if you think your examiner is going to be mean. Part B. So that was a nice, easy 1 mark, and it's probably going to be leading you into something. Jan cuts out the maximum number of circles from the card. So we just worked that out, we know that's 40. What area of the card is left? Left over. Okay, well, what's the current area of the cards? Let's do it. If we go to the previous page, so the current area, that will be 96 centimeters times 60 centimeters. Okay, so you can say card area. And we can work that out in a second. Okay, so how much area is taken away? So we're cutting out these circles, we're taking them away. So you could say circle area. Well, you know, for one circle, the area is pi r squared. And you've just been told r, that's 6 centimeters. So for one circle, it's pi 6 centimeters squared. And then you've got 40 circles, you've got 40 times that area. So then the area of card that's left over, it's going to be your card area minus this circle area. That's your final answer. So let's just start plugging these into your calculator. Our nice calculator there. Start off with the top one. So 96 times 60. So that's 5760 centimeters squared. This unit of area, and these are in centimeters. So now let's do our circles. So we're going to have 40 times, and let's see where pi is on this calculator. We've got pi down at the bottom for us. You should familiarise yourself before the exam where your pi is. So because it's at the bottom and it's in yellow, I'm just clicking the shift button, which corresponding yellow colour, and then I click the pi symbol, that's in, and it's times 6, and I've done 6 squared. And we don't want it in terms of pi, we just want the number. So we're going to click change the format. So 4523 point. Let's leave it to 2 decimal places just to be sure, because we don't want to round too much too early and then it comes out with the wrong answer. So that'll be 89 centimeters squared. So let's do that final subtraction. So we've got our card area, we've got our circle area. Let's find out for the final mark how much is left. 5760 minus the answer that we just had on equals, and then it's 1236. 236, and we'll do it to 1 decimal place this time, 0.1 centimeters squared. You want to put that in your final area for the answer. Question 23. So the previous question, 22, that was very calculator heavy, so they thought, okay, we'll give your brain a rest, we'll go back to the basics of maths, we'll do a bit of algebra. So as you should know, when you're expanding the bracket, you start with the first term in the first bracket, and you times it by the first term in the second bracket, and then we're going to times the second term in the second bracket, and then you'll do the second term in the first bracket, multiply it by the first term in the second bracket, and multiply it by the second term in the second bracket. So we'll do this first, we'll do this second. So we're going to have x times x, which is just x squared, plus 7x, and then we're doing plus 3x, because it's 3 times x, and then plus 21. And now we're just going to simplify, because we've expanded it, we've done step 1, and now we're going to simplify. So we've got x squared, there's no other x squareds, we've got this 7x and this 3x term, so we put them together to get 10x. And then there's no other numbers, it's 21, and that's the end. Next, we have a solve question. So when it says solve, it wants you to get what is that value of x. So you want to get all your x's on one side, and you want to have it equal to just 1x. So first of all, we're going to take away 4x from each side. Let's get on one side. So then you get 3x plus 6 equals 7. So you're going to move the numbers from that left side to the right side, minus 6. So we'll get 3x equals 1. And then the final step, do it here, we're just going to divide each side by 3 to get x on its own. So x equals 1 over 3. Next up is factorising y squared minus 400. So you're very lucky because you've got your calculator for this one. So anytime that you see this x squared minus and then some number, that some number is always going to be a squared number. So when you're going to put it in the brackets, it's going to have the form. So your y is there. So you're going to get your 2 brackets, y, and it's going to be plus the square root of this and minus the square root of this number. That's a little trick. Because I don't know that off the top of my head. Some of you may know it. I'm just going to get my calculator out, clear it, and put in square root of 400. And that's just 20. Just put a 20 in there, slot a 20 in there, nice easy mark. And then finally, it says solve the following simultaneous equations. You must show all you're working out. So the first step is we want to get either x or y in terms of the other variable. So one of these equations, and this one looks easiest here. We want to get it to have x on one side or y on one side. We'll stick with x to make it easier. So we're going to do x plus y equals 3. To get the x on one side, we're going to minus y here. They cancel out. Equals 3 minus y. Now we have x in terms of y. So this value here, we can just slot into, and I'll put a label now here. Call this equation 1, we'll call this equation 2. We're just going to slot this substitution into equation 1. So that means you'll have 7 in brackets, because it's going to be timesing everything in these brackets. 7 times 3 minus y minus 3y equals 26. So now we just have an algebraic equation in terms of just y, so we can solve for y. And we'll think about x a little bit later. So if we expand these brackets out, so 7 times 3, you get your 21 minus 7y minus 3y equals 26. So now you're going to gather your y's, so you're going to have 21 minus 10y equals 26. You're going to put your numbers to one side, so you can have minus 10y equals, and we're just going to minus 21 here, minus 21 here. So it's 5. So then we're going to divide by minus 10, divide by minus 10. So then we'll get just y equals 5 over minus 10. Let's make that a little bit simpler. So you could do that as 1, 2, don't drop the minus. So we've got the value for y. That's minus 1 over 2. So now all we need to do is substitute that value for y back into, and we'll stick with the easy equation to get our value for x. So we'll have x minus, because we're just putting y straight in, minus 1 over 2 equals 3. So now we're going to add 1 over 2 on each side. So that gives us x equals to 3 plus 1 over 2, or you could just call that. Then to combine your whole number and your half, you can write this 3 as, you're just going to do 3 times 2, so that's 6 over 2. So this 6 over 2 is exactly the same as 3 plus 1 over 2. So you can write this as 7 over 2, which is equal to 3.5. So now we need to write that at the bottom. I've just checked the mark scheme. For some reason the examiners have been exceptionally mean this time around, and they want this y to be in its decimal form. So that'll be minus 0.5. So just in case for these questions, just put them into decimal form. Question 24. The two shapes below are similar, and we can visibly see, yes, they are similar. There's some sort of arrow shape. And it tells us just below that diagram, the diagram is not drawn to scale. So that gives us the hint that we're not using a ruler. We can't measure the unknown lengths. Then it says, find the values of r and the values of t. So the value of r is on this left-hand shape, the value of t is on this right hand shape. So we're going to make the assumption that this left hand shape is just a scaled up, like bigger version of the right hand shape. So because of that, each one of these sides, for example, I'll label this one, so this back end here, and this back end here, over here, on these different shapes, they're going to scale by some sort of factor. We don't know what that scaling factor is, but we do know that the ratio between all of these sides is going to be the same. So the ratio between, so we'll call this A for now, we'll call this B for now. So on shape A, the ratio between this first side here, so 15.6, and we're going to write this as a fraction, so that over 19.5 is going to be equal, to the ratio of side 1, 10.4, over side 2 on shape B. So now that we've got this ratio relationship, all we need to do is solve for t. So we're going to times each side by t to get the t on top. So we'll have t 15.6 over 19.5 equals 10.4. And then we're going to times by that fraction there flips the opposite way up, because that'll cause that fraction on the left hand side to just disappear. So we're going to times it by 19.5 over 15.6. Going to do the same on that side. 0.5 over 15.6. So we'll end up with t equal to 10.4 times 19.5 over 15.6. So now we're going to get the calculator out, because I can't possibly do that in my head. So we're just going to type that in. So 10.4 times, and we're going to use this fraction sign, 19.5 over 15.6. So that gives us t equal to 13. Now, because I'm writing quite big and using this software, I've run out of room, but we're now going to solve for r just to, we'll do it to the right hand side over here. So the exact same thing as what we did to solve for t. We're going to label r as side 3. Label this as side 3. Because of these shapes scaling by some scaling factor, we know that the relationship of 1 over 3. So side 1 over side 3 is going to be equal to side 1 over side 3 in shape B. So if we now substitute that in, so we'll have 15.6 over r equals to 10.4 over 7.6. So same again, we're going to multiply by r on both sides, and then we're going to multiply by this fraction here, but flip the opposite way up, which would give us r equal to 15.6 times 7.6 over 10.4. So now if we put that into our calculator, that gives us 11.4. Now we just need to put that into the final box at the bottom. So that t was 13 and our r was 11. Question 25. Vaughan cycles down a track from the top of a mountain to the bottom. And we've got a nice little visual of the track there. It looks pretty steep. He's a pretty extreme person. The track goes down at an angle of 48 degrees to the horizon, and we can see that on our diagram here. Vaughan is 800 feet above ground level, and we can see it there on the diagram. So that means that all this information that we've just read at the top is in our diagram. We don't need to read it again. Part A. Vaughan cycles from the top of the track to the bottom of the track. What distance has he cycled? So he's starting at the top here. Oh, it's even labelled. Vaughan's labelled on there. And he's going down the track here until he gets to the bottom. And I've drawn that line on there because you'll start to notice that this track with this line here and this little square, that's actually a right angle triangle. Yes, if we now take away the line again, the track's a little bit wonky. It's not completely straight, but it's close enough. It's close enough for triangle. And we want to know what this distance is here. Well, knowing right angle triangles, we know that this long side here would be the hypotenuse. That's the longest side. And this side here would, well, actually we can't say what that is yet until we have what our angle is here, or our angle here. So both of these are pretty easy to work out, because in a triangle, you know that it has 180 degrees. At the moment, you have 90 degrees here, and you know that there's 48 degrees here. Now, because that's a horizontal line, so that means horizontal with the ground, i.e. it's parallel with the ground. In total, this angle here would be 90 degrees. That means that this angle inside the triangle would be something that when you add 48 degrees, it equals 90 degrees. So if we do 90 degrees minus 48, we get 42. Now we could try and work out that last angle here, or you might have worked that out first. However, we've got this. We don't need anything else. Because now with this angle, we can see we've labelled our hypotenuse. Our opposite would be opposite to where the angle is. Then our adjacent here would be the 800 feet. Now you might be asking, okay, it's in hypotenuse, adjacent, you talk about triangles, it might be ringing some bells. These are all in reference to the trigonometry equations. Now this is how a lot of people remember it, is so ka to a. So now if I split that up, so you might just hear SOHCAHTOA. You're told to remember like this arbitrary made up list of sounds, but what them letters actually refer to is, so for example, with the first one, that S means sine. So sine of an angle would be equal to the opposite over the hypotenuse, or the cos of an angle would be the adjacent over the hypotenuse. So remembering this phrase gives us a list of actually 3 equations we can use to solve this. So if we have a quick look again, we want to find what h is. This is what we want. We currently have the adjacent, we have this a. So there's only one of these 3 equations here that has a and h. That's the middle one, cos. So you can then say cos, you have your angle there, 42 degrees, equals to your adjacent, so that's 800, over some length here, h, we don't know what it is yet. Because now you've done a lot of the steps. I think to this point, you've probably got 3 marks. You've looked at the diagram, you've gone, yes, that's a triangle. You've labelled the sides, you've found out more information about it from what you know about triangles. And then you've gone, okay, I remember this SOHCAHTOA phrase, here's my equation. But now you have to solve this for the hypotenuse. So to do that, we're going to times that hypotenuse up, and we're going to divide by cos 42. I'm doing that in one step because it's almost the end of the paper and we want to get everything done ASAP. but you could always do it in 2 steps if you're not as confident. So by timesing by h, dividing by cos 42, we then get, and I'm going to write this over here because we're running out of room, that h equals 800 over cos 42. Now this we can just plug directly into our calculator. So now we've got our calculator up, we're going to say fraction 800 over cos, so we just click the cos button, 42, and then we're going to close that bracket. And make sure when you're doing this that your calculator is in degrees mode. You should never have changed it to radian, but if you're getting really weird results coming out and you're like, hang on, how is the hill like only 10 feet long but it's 800 feet high? That's because your calculator is in radian mode instead of being in degrees mode. So if you're not sure, or if you've not heard that before, just talk to your teacher about it. But the short of it is don't change the mode of your calculator. And that gives us 1076, and we'll leave a decimal place. So 1076.5. We've rounded to 1 decimal place there. Part B, I. State an assumption you've made in answering part A. Well, the first assumption we made when we were looking at it and talking about it was that this hill was straight. We even acknowledged before we started, okay, this hill's not quite straight, but it's basically a triangle. So we're assuming hill is flat. And we're also assuming, because as I initially said, that's a really, really steep hill. If you're going to cycle directly down that hill, you're going to get a lot of speed. You're going to be going pretty speedy. But, you know, most bike tracks down a hill don't go directly down it because that would be crazy. You might take like a more roundabout route. You might take a nice route. All we know is he's gone from the top and then he's got to the bottom. He may not necessarily have gone in a straight line. So we've also assumed, and his route was straight. Part II. If your assumption is not correct, so if all the things we've assumed isn't right, what effect would this have on your answer to part A? So this is actually easier to show if we just graphically draw it out. So in our assumption, we're assuming, well, that's a terrible straight line, but assume that's super straight. Now, say if we actually had how the hill really is, where it's a bit wiggly going down, and then you straightened out that wiggly path. We'll label this 1, we'll label this 2. Well, number 2 would be much longer. It'd be a longer distance. And say, okay, for our other assumption that his route was straight, say that actually he took a really nice roundabout route, he's doing this, he's doing little wiggles, he might have stopped. And then we straighten out this path. Path 3 would also be a lot longer. So what that's telling us is if the assumption we made that it's a straight line and he took a straight path wasn't correct, then the distance that he cycled would be a lot longer. So that's all you need to write. So distance cycled would be longer. So once again, this has been John with Page Tutoring. Hopefully that was a helpful cover of Eduqas's Autumn 2023 Mathematics Calculator paper. If you'd like to see more content like this, feel free to like this video and to subscribe. Hope to see you again soon.